We're on the last lesson of Chapter 7, which is to graph linear inequalities in two variables. So we're going to do that first. Next, we're going to be graphing a linear inequality in one variable, and then we'll solve a real-world problem. A couple things to notice when we're graphing inequalities. It works very similarly to graphing equations, as in you still need to make a line. When you see y is less than negative x plus 3, we see the y-intercept at 3 and then a slope of negative 1. So you're creating that line. And then everything that is underneath it here would be true since y is less than that. For example, when x is 0, y is anything less than 3. When x is 2, y is anything less than 1. And so that's why it's all shaded in, because all of these here in this area could be true. Same thing with this one. The difference between this and this, you'll notice, is the less than or equal to here, and just the less than here. So what I do is I make a dashed line for the less than because these values aren't absolute, whereas this one is, so I just have a straight line for the less than or equal to. So let's graph some inequalities. I have y is greater than 4x minus 3. So if I want to graph this inequality, I can start with the line. I know that the y-intercept is minus 3, and then the slope is 4x, so positive 4. So run of 1, rise of 4, run of 1, rise of 4. So now that I have these dots, I can create my line. I need to make a dashed line though, because it is greater than and not greater than or equal to. So if I'm going to start at this point, make my dashed line going through these points. Let's extend that line then. I see that y needs to be greater than this line. So this line is here at negative 2, y could be anything above negative 2. If the line is at 0 here, y needs to be above 0. So if I'm going to color this in, I'm going to fill in this whole area to show that all these values will work for y. So we have a standard form inequality here. Let's turn that into slope-intercept form. So subtract x from both sides. So we have 2y is less than or equal to negative x plus 0, or just negative x. Then we can divide both sides by 2. So y is less than or equal to negative 1/2 x. So the y-intercept is 0 because there's nothing being added here. And the slope would be negative 1/2. So run of 2, fall of 1, run of 2, fall of 1, run of 2, fall of 1. Then I can use these points to plot. And I'm going to use a regular line this time because it's less than or equal to. So if I extend it backwards, and there it is. And I see that y is less than or equal to. So y needs to be less than whatever this line is. So I'm going to fill in anything underneath this line to show that y's are always going to be in this area. Alright, good enough. Let's graph these inequalities then. Y is greater than or equal to negative 3. There's only one variable here. So that one's a pretty simple line, and since it's greater than or equal to, we can have a solid line. So y at negative 3 would be here. And if y is greater than or equal to it, I'm going to color everything above it. I got a little over that line, but I can erase that later. I have x is less than negative 1 then. So we're looking at the x values if we're making our line. And it's a dashed line because it's just less than negative 1. So if I draw my line here along negative 1 for x, it's going to be less than that. So it would be on the smaller side of that number line. So if I'm going to color that in, I'm going to color the left side for x. So all these values for x would work if x is always less than negative 1. Let's solve a real-world problem then. You have 2 summer jobs at a youth center. You earn $8 per hour teaching basketball and $10 per hour teaching swimming. Let x represent the amount of time in hours you teach basketball each week, and let y represent the time in hours you teach swimming each week. Your goal is to earn at least $200 per week. So it says write an inequality that describes your goal in terms of x and y. Well, I know the goal is to earn at least $200 per week. So at least looks like this, greater than or equal to $200. And then I need to figure out how can I earn that. Well, X is the time in hours you teach basketball. I get $8 per hour teaching basketball. So X is the hours times 8 because I make $8 per hour. Then I'm going to add whatever I do with swimming. Y is the hours I spend teaching swimming. I make $10 per hour teaching swimming. So it'd be plus $10 per hour times the number of hours I teach it. So this would be my inequality. 8 times X plus 10 times Y is greater than or equal to 200. And I can graph this using the intercepts. So I could change the X into a 0, for example. So 8 times 0, which is just 0, so we'll erase that, plus 10Y is greater than or equal to 200. So if I divide both sides by 10, 200 divided by 10 would be 20. So when X is 0, Y is 20. We got that point right there. Make it nice and big. Then we could find the x-intercept by making y 0. So we would say 8x plus 10 times 0, which would just be 0, so we'll erase that, is greater than or equal to 200. So I divide both sides by 8, and that'll give me 25. So the x-intercept when y is 0 is 25. And now that I have my intercepts, I can graph that line. Since it's greater than or equal to, I can do a solid line and match those points up. So then all of these answers would then be a solution. All of these would give me a solution greater than $200 if I teach these various combinations. For example, if I taught 30 hours of basketball, that would be more than $200, even if I didn't do any hours swimming. 30 hours basketball, 0 hours swimming. And I'll write the other two up here. So I could do 40 hours of swimming and 0 hours of basketball and still get it. So 40 hours swimming, 0 b-ball. And I could do something in the middle here. I could do 20 hours of basketball and 30 hours of swimming and make a lot of money. So 20 hours b-ball, 30 hours swimming. And there's many other combinations I could use. Anything on this grid, anywhere in the green, I could plot a point and then find out all those hours to make me more than $200 a week.